Welcome back to The Explainer. Today, I'm putting on my hat as the strategist. We're going to completely decode the assessment mindset and finally bridge that super frustrating gap between a B and an A star in Cambridge AS and A-level mathematics. Specifically, we are locking in on topic 3.9, complex numbers. Look, if you've been struggling with the addition, subtraction, multiplication, and division of complex numbers, it usually isn't because you can't do the math. It's because you aren't playing the game the way the mark scheme wants you to play it. We're going to change that right now and learn how to work smarter, not harder.
Here's our roadmap for today. First, we'll cover the trap. Next, the blueprint. Then, the system. And finally, mastery. Let's dive in. All right, section 1, the trap. The stakes for topic 3.9 are absolutely incredibly high. Grabbing those top grades isn't just about having raw mathematical facts crammed into your head. It actually requires analytical depth and cross-topic connections, instead of just relying on superficial breadths and isolated facts. You know, the syllabus prioritizes structured reasoning way over rote memorization. Grading reports constantly highlight that candidates who integrate complex numbers with other areas, like literally linking coordinate geometry to the Argand diagram, end up achieving significantly higher marks. It's all about depth, guys, not just skimming the surface.
So what exactly is tripping people up? Well, we went straight to the principal assessment reports for topic 3.9, and here are the top 3 mistakes rapid fire. First up, vague answers. The graders absolutely do not want generalities. They want specific, concrete mathematical details. Second, formatting errors. Students get so caught up in the weeds of calculating a conjugate division that they completely forget to check their final presentation. And third, ignoring the context. If a question gives you a specific context for a complex number problem, your final answer has to directly relate back to that context. Do not just leave a floating complex number, like say 3 plus 4i, alone on the page without explaining what it actually represents.
Moving right along to section 2, the blueprint. Now that we know exactly what to avoid, let's shift our focus to the active, systematic strategies you actually need to succeed. There is a massive alert in the examiner reports regarding confused terminology. This brings us to a golden rule, the terminology rule. Establish your definitions before you jump into any calculations. If a response needs you to use specific terminology, say talking about moduli or arguments, define exactly what you are doing first. This proves to the examiner that you understand the underlying concepts of a complex number's magnitude and angle before you just start blindly crunching the algebra. Which brings us perfectly to the method mark strategy. In Cambridge Math 9709, marks are awarded heavily for the process. Look, getting the correct final complex number is great, but showing systematic analysis and clear algebraic steps, that's where the real points are won. When you're dividing by a complex number, for example, show the exact step where you multiply the numerator and denominator by the complex conjugate. You have to show them exactly how you got from point A to point B. Your working out is essentially your argument for why you deserve that A star. Okay, let's get into section 3, the system. Let's turn this underlying philosophy into a concrete, actionable workflow. It's a 5-step standardized sequence. Think of this as your mathematical assembly line. Step 1, identify the key elements, like isolating the real and imaginary parts. Step 2, apply the relevant principles. This is where all those complex number rules come into play. Step 3, execute your analysis with exceptionally clear working. Step 4, verify your results. Honestly, just make sure they mathematically make sense. And finally, step 5, present your answer in the appropriate format requested by the command word. This procedural framework is the exact system the assessment criteria use to award consistent marks. Remember, when we apply this specifically to topic 3.9, executing this sequence requires a bit of prep work up front. The foundational step is data interpretation. Before you even think about beginning your calculations for addition or division, you absolutely have to carefully extract the correct data from any text, tables, or complex problem descriptions they provide. A single misread value at step 1 corrupts the entire sequence, making all your subsequent working totally irrelevant. And finally, section 4, mastery. We are now transitioning to the absolute highest level of assessment. These exams are built on a framework of increasing difficulty, and it's what separates the good students from the truly exceptional ones. At the very bottom, we have the descriptive level. That's simply extracting data. The middle tier is analytical, breaking those complex number problems into logical, algebraic steps. But the top tier, the evaluative level, that requires you to actively question assumptions and justify your mathematical decisions with rigorous evidence. That is your ultimate goal for top marks. Which naturally leads us to a really crucial question. How do top-scoring candidates actually demonstrate this kind of true evaluative thinking in a high-pressure exam environment?
Well, it looks exactly like the deconstruct, solve, evaluate methodology. Top students don't just dive in and solve, they deconstruct first. They break the problem into logical steps, solve it systematically while showing every single method mark, and then, and this is the absolute critical part, they check for reasonableness. For example, asking themselves, does this argument value actually fall in the correct quadrant based on my real and imaginary parts? Verifying reasonableness and making justified mathematical decisions is exactly how you secure those final high-tier marks.
This quote, straight from the Cambridge Syllabus Principles, perfectly sums up our entire strategy for today. It reads, top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. True mastery really means that when the exam inevitably throws a bizarre, unfamiliar curveball your way, you don't panic. You simply adapt the structured strategies we've discussed today to break it down. I want to leave you with this final, provocative thought. The next time you sit down to practice, you really need to ask yourself, are you just rote memorizing math facts, crossing your fingers and hoping to scrape by? Or are you truly ready to systematically deconstruct your next complex numbers question using the blueprint we just outlined? Start applying this framework to your past papers today. Focus on the method, and I absolutely promise you will see a massive shift in your understanding. Thanks for hanging out with me on The Explainer today, and keep learning.